window. Yeah. Okay, so let's pick up where I just left off for the last segment on the sine function. A question came up while they were setting this segment up regarding the graph. So let's now do the graph. We have a table of values shown here. You can see that on the screen. Table of values shown. Talked about the odd character of the sine function. And now what we want to do is go back to y equals. Here's our function. And let's go ahead now and generate a graph of this. So the next step in graphing, once you enter your function, well, usually you do all this stuff on paper first, right? You do your stuff on paper, and then you use your calculator to sort of confirm your calculations on paper. We now go to Window, and I'm going to go ahead and set this up so it goes from minus 90 degrees. Let's go past 360. If I added 90 to 360, I'd get 450. And let's put tick marks every 90 degrees. And vertically, minus 1.5 to 1.5, because we know the range can't exceed a value of 1 or negative 1. And then let's put tick marks every 1. If I hit graph now with those and for note taking, you only need to write 6 numbers down. Next step on your notes would be to draw a box that represents your viewing window on your paper. And we should see this nice, smooth looking graph. And I can spot check this at a few data points. Like if I'm at 30 degrees, back to the graph. If I hit trace and then punch in 30 degrees, you can see clearly we get exactly 1/2. When you're doing hand sketching, I've taught trig quite a few times over the years. Don't draw triangles, please. That upsets me because these are not linear functions, okay? Do not draw triangles, okay? Draw a smooth wave, okay? Be artistic about it. When I try 45 degrees on trace, I'm at the square root of 7, or square root of 2 over 2, which is 0.707 approximately. And you can see different values here. Look at the symmetry. Watch where my pencil is. At 90 degrees, you can clearly see symmetry to either side of 90 degrees. Everybody see the symmetry? Go back to your unit circle and think about the sine readings to either side of 90 degrees. 80 degrees versus 100 degrees. You with me on that? 80 degrees on your unit circle, 80 degrees versus 100 degrees. The y readings there are identical, aren't they? So to either side of 90 degrees, and on this function, you can see the symmetry to either side of 90 degrees. Similarly, you can be at 270 degrees over here. And think of the symmetry that exists to angles to either side of 270 degrees. So these functions have symmetry, and it's not just odd behavior, but you actually can be at another location and observe the symmetry. Okay? Very important. Are you ready for the next function? We've got 6 of them to do, don't we? Right? 6 of them, because there's 6 trig ratios. So let's look at the second most important one, which is the cosine function. So let's come back to the board. This time we're going to be looking at what values off of the unit circle? The cosine values, Austin, which are which values on the circle? The x readings. The x readings on the circle. Okay? Now what I'm going to do is I'm going to just come down below this rough sketch of the sine here. And I want us to go ahead and draw, and I'm going to use the same angle scaling. So I'll try to line up here 360 degrees, 180. Oh, when you're drawing, you're going to be doing a lot of sketching on your graph paper. You'll find the period of the function. In this particular case, we know the cycle necessary to complete a cycle and start over the behavior is 360 degrees, called the period. So what I would typically do is I would select how far on my graph paper I wanted to be the end of a period or a cycle, and I would mark that, and then I would cut it in half, and then I'd cut that in half. So I'd be looking at my quarter cycle points on my scaling. Okay, everybody hear that? You're going to use that thinking all throughout this course. You're going to figure out what the period is, or the amount of angle, or oftentimes time, necessary to finish a cycle. And then you're going to lay that on your graph paper, you're going to cut it in half, and then you're going to cut it in the period into quarters. And you're going to use those kind of marks for your scale marks, typically. So you can pretty nicely lay it out. Now, let's start thinking about not the sine again, but let's think about the cosine readings. So at 0 degrees, just mentally image your unit circle. Mentally image the unit circle, and so you're thinking on your unit circle at 0 degrees, you're out here, and the length of my forearm here to get out there is 1, isn't it? So my cosine reading is 1. So I'm starting up here at the top at 1 at 0 degrees. Why don't you folks, with a pencil on your paper, see if you can sketch the rest of that graph through one cycle, Think about the unit circle. Think about what's happening to the x readings. Starting at 0 degrees, you're at 1. And then as you move towards 90 degrees, what's the x reading when you get to 90? When you're at 90 degrees, the cosine is 0. And then once you go past 90, they're going negative on you, aren't they?
Yeah.
Towards -1. They're -1 when you get over here. So keep on sketching. And I'm just going to keep rolling here because of the recording. As we move our angles towards 90 degrees, the cosine, the x readings are coming down in value from 1 towards 0. And when you get to 180, they're at -1. Down here at -1. And when you get to 270, they're back to 0 again. And when you work your way back to 360, they're back up to 1 again. The x readings. Is the pattern any different, though, than the pattern that we saw in the sine? Don't the numbers vary in a similar fashion as the angles roll? Okay. If you don't believe it, what would you do before you touch your calculator? You would mentally split 90 into thirds, and then halfway between 30 and 60 is where 45 sits. We're on our 16 familiar angles then. And at 30 degrees, we know the cosine is, at 30 degrees,
Square root of 3 over 2.
is square root of 3 over 2 is the cosine reading there at 30 degrees. And so we're gonna, at 30 degrees, we're gonna plot 8.866. And when we're at 45 degrees, we're gonna plot something a little shorter. Square root of 2 over 2. And then when we get to 60 degrees, it's gonna be even shorter, at a half. And it's gonna come on down just like the sine pattern. And then when you go past 90, degrees, the x readings on your unit circle become negative. And so they head down towards -1 in value, and then past 180, they cycle back up, and then they continue on up like this. And the angles can go clearly past 360, and they can go clearly negative as well. So here is a nice graph of the cosine function. Feel good? I see most heads going up and down. Anybody's head going horizontal? In a harmonic motion? No? Okay, that's good. We want them to go up and down. Okay. Tim, what do you think? Okay. So what we're doing is we're doing just like we did back in algebra, where we did something like with x cubed, where we plotted data points, we made an observation about what the table of values look like, we translated the table into a graph, and then we start looking at the graph. So that's all we're doing. And we're making a connection back to this unit circle. Now, let's look at this for just a second. If I'm on my unit circle and I find the cosine of angle theta, and here's a sample angle up here. The cosine of my angle theta on this unit circle is that distance between my fingers, isn't it? Now, what if I find the cosine of negative theta? The cosine of negative theta. I make my angle. Here's my angle. Where distance between my fingers is still the cosine of angle negative theta, and they're identical, aren't they? That's identical to whether the angle is positive theta or negative theta. So the reading of the cosine of theta is the same as the reading of the cosine of negative theta. That output value is the same as this output value. This is analogous to writing f of x equals f of negative x, which means the cosine is what kind of a function? It's an even function. It's an even function. You can also look at the graph. You can look at the graph of this cosine function, and you can see that if you're at some angle theta here, the cosine reading is here. If you go symmetrically over to negative theta, it's got the same output values. Cosine of negative theta here is the same as the cosine of theta here. Cosine is an even function. That's 2 of our 6 functions. This is 90% of the work right here. 90% of the work is right here. Okay. So all you have to remember, if you've got a nice smooth looking wave, just like the tides or the waves rolling in towards the shore, nice smooth little wave cycle going on, and one graph looks just like the other, except what do you observe that's distinctly different about the two graphs? I mean, one's odd, one's even, but the shapes are identical. Right. Okay. A cycle could start, actually, a cycle could start anywhere, couldn't it? Couldn't I start it right here? True. And I could go out this far? Right? Okay.
One has a symmetry towards the origin.
Odd function. And this one is an even function, has y-axis symmetry. That's good observation.
I think what you're saying, we're trying to get at is there's a shift.
Ah. Remember that in algebra? You used to take parabolas and shift them right or left. Sometimes you'd shift them up and down. Sometimes you'd stretch and squeeze them. That is the transformation stuff. But you can observe the shape of the graphs are identical, but there is simply a shift going on to make one match the other. Make one match the other. So, where does that bring us? Transformations, doesn't it? So, let's see. What happened to my eraser? Oh, there it went. Let's see. What if I shifted this sine graph back to the left? 90 degrees. Wouldn't that match this thing? Yeah, interesting. If I shifted this graph back to the left. So these are clearly functions. Both pass vertical line test. Both have domains of all real numbers. And both are trapped in the range between a minimum value of -1 and a positive value of 1. Up to and including those values. So, do you remember how to shift a graph? Okay. What variable are you messing with when you horizontally shift a graph? Think about it. If you're doing something this way, you should be messing around with the independent variable. Usually in algebra it's x. In trig it's usually an angle measure. Okay? So in this case we're going to be playing with the theta variable. So if I want to shift a sine graph to the left, I want to shift it to the left by 90 degrees. I'm going to be then getting some new theta readings. I'll get new theta. Okay, I'll get new theta values. So, if I want to shift a graph to the left, I want to take my old theta values. And I want to subtract, don't I want to subtract 90 degrees from the old theta readings? If this is my old original graph that we have in our head, the elementary function back here. This is the old graph. So the old theta readings I want to subtract 90 degrees from to get the new theta readings. So look at what the old theta is going to have to be. The old theta is going to have to be replaced with, if I add 90 degrees to both sides, it's going to be this new theta reading plus 90 degrees. So I take this old function up here, where this is my old theta, and I'm going to replace that old theta with the new theta plus 90 degrees. So I'm going to get y equals sine of theta plus 90 degrees. And that's going to end up being a cosine graph. That's going to be a cosine graph. So this is going to be equal to the cosine of theta. This is no different than back in algebra, you looking at a graph something like this. That is your simple parabola x squared shifted 2 to the left and sitting here like this. So if you see something like this, the sketch of that is going to be a cosine graph through a period or a cycle of 360 degrees. Here's the equation, here's the sketch. How do we check to see if this story is correct? Or do you just always believe me? Well, yeah, we could put our calculator in degree mode, and we could go to our calculator and see what the sketch looks like. See if it is a cosine graph. So we can come back to the calculator. And I come back in here, and I'm going to change this to be the sine of x plus 90, close the parentheses. I still had the window settings from previously, same window settings. Here's, I changed the function to be this, and I hit graph, and there it is. What you can observe is the key, the critical points, such as this maximum up at 1, the 0 occurring here at 90, the minimum occurring at 180 degrees, another 0 here, a top, another maximum, and back to a 0. Okay? All right. So shifting, one thing you can remember, whether you're in this course now and this is fresh in your mind or later in other courses, is a sine and cosine are the same graphical characteristics. One is just the shift of the other. One can just be a horizontal shift of the other. All right. I want to practice something. If I came back real quickly and just made this the sine of x, again, here's the picture. What's another shift I could do to get a cosine graph? Besides shifting the sine graph 90 to the left, well, if I went 90 to the right, that would drag this minimum to here, wouldn't it? That would be an upside down cosine graph. Remember that stuff? Turning things upside down? Okay, but what if I wanted to make a new a regular cosine graph out of this, but I don't want to do a shift to the left of 90. Shift to the right of 270. Should we try it? See, I'm not seeing that 270, but let's think. If I go off to the left, I'd be coming back up to 0 if I went another 90 to the left of this picture, and if I went back another 90 after that, I'd be up at the crest, wouldn't I? And that'd be 270 off there to the left of this picture. I'd be back on the top. So I want to do that, and I want to shift that to the right like you suggested. So I go back here. I'm going to shift this to the right, 270. So I put in what? Remember doing subtraction? 270. And hit graph. And I'll close the parentheses and hit graph. Feeling good. Okay. So there's multiple ways you can shift these sine or cosine graphs to be able to make them turn into the other function. Okay. So we started the course by learning patterns from we first of all learned angles. Really important angles. And then after we learned a bunch of angles, then we started talking about the trig ratio definitions, and we used the unit circle to help us get some of that into our head. And now we've translated information from that unit circle onto these graphs, these actual functions. And we're getting into the stuff you're familiar with from algebra. How many of you are rusty on that algebra stuff? of shifting graphs and stretching, squeezing them, and so forth, okay? There's a set of DVDs available from the college algebra class I taught last term, and all you have to do is come to the Resource Center and look at the list of DVDs on the college algebra material on transformations, and that might be worthwhile for a few of you to watch a few of those. Okay? That's sine and cosine. Let's go ahead and let's end this segment on the cosine now, and then we're going to go ahead and review transformations in the next segment for a couple minutes.